Okay, to graph this rational function, we can first look at the first terms of each, and we can see that they're the same degree, same. So we take the ratio of the coefficients 2 over 1, and we get y equals 2, and that's the horizontal asymptote. At the horizontal asymptote, when x goes to the right, y is going to get closer to 2, and when x goes to the left, y is also going to get closer to 2. That's what a horizontal asymptote does for the end behavior. Since nothing reduces out, we take the denominator and set it equal to 0, and that gives us the vertical asymptote, because the denominator cannot be 0. And since nothing reduced out, there isn't a hole. To find the x-intercept, the fraction has to be 0. For a fraction to be 0, the top has to be 0. Solve for x, we get 1/2. 1/2 comma 0 is the x-intercept. The y-intercept, we plug in 0 for x. All the x's go away. We get negative 1 over negative 1, which is 1. So the y-intercept is 0, 1. Now, to draw the graph, there's something else we can do. I can look at what is called the critical values. The critical values have to do with the x-intercept and the vertical asymptote. So at 1/2 and at 1, we have critical values. To the left of 1/2, if I plug in 0 into this original function, I'll get a negative over a negative, which is positive, which means to the left of a half, the graph is positive. So here's the half. To the left, it's positive. It's got to go through the y-intercept, and then it's got to go towards but not touch the horizontal asymptote. Let's test between the 1/2 and the 1. So I'll plug in 3/4, and I don't have to plug it in exactly, because here's what I mean. 2 times 3/4 is bigger than 1, so subtract 1, it's positive. And then 3/4 minus 1 is negative. A positive over a negative is a negative, which means between 1/2 and 1, the graph goes down towards the vertical asymptote. To the right of 1, to the right of the vertical asymptote, I'm going to plug in 2. You can plug in anything you want to. I'm going to plug in 2. If I plug in 2 here, I'll get a positive on top and a positive on the bottom. A positive over a positive is a positive, which means to the right of 1, the graph is positive. So it's always got to be above the x-axis, and it's got to go towards the 2 asymptotes. If I draw it this way, towards the 2 asymptotes, this part's negative. I put in another x-intercept which isn't there, and so that has to be wrong. So this critical value test, we'll do this a few more times, and I'm hoping it's going to help you graph the rest of this graph. If we do the division, I did synthetic in this case, I'll get 2 plus 1 over x minus 1. As x gets bigger and bigger and bigger, this becomes essentially 0. So at the end, the graph is going to equal y equals 2, or look like y equals 2. And sure enough, the horizontal asymptote, or the end behavior, is y equals 2. Here, I factored, and then the x minus 3 reduce. and I'm left with this fraction. But we want to remember that x still can't be 3 from the reduced portion. That's where the hole is. Okay? The degree of the top is 1, 2x. The degree of the bottom is x squared, or 2. And so it's bottom heavy. And if it's bottom heavy, the horizontal asymptote is y equals 0. And here is the end behavior. To the right, it goes to 0. To the left, it goes to 0. So when we reduce this, the x plus 3 is still in the denominator. So x equals negative 3 is the vertical asymptote. But this 3 also contributes to something that's undefined. So at x equals 3, I plug that into the reduced fraction, and I get 2 over 3 plus 3, which is 2 over 6, which is 1/3. So at x equals 3, y is 1/3, there's a hole there. Intercepts, I can take the reduced portion and set this equal to 0. When a fraction is 0, the top is 0. Well, the top can never be 0, so there isn't an x-intercept. To find the y-intercept, we let x equal 0 into the reduced portion, and sure enough, we get a number, 2/3. So at x equals 0, y is 2/3. We have a y-intercept and no x-intercept. Obviously, there's no x-intercept because the horizontal asymptote is y equals 0, the x-axis. You don't touch that. Critical values are at the vertical asymptote and x-intercepts, but because there isn't an x-intercept, all we have to worry about is the vertical asymptote. To the left of negative 3, like if I plugged in negative 6, let's take this over here, 2 over x plus 3. If I plug in negative 6 here, I get a positive over a negative, and that's a negative. And then to the right of negative 3, if I plug in 0, I get 2 over 3, or a positive over a positive. So, to the left of negative 3, it's negative, and to the right of negative 3, it's positive. Well, asymptote here, asymptote here. If I do this, they go towards both asymptotes, but it's positive. We just said it was negative there, and that's why we drew the graph below here. To the right of negative 3, we said the graph is positive. If I go towards the asymptotes here, that's negative, and there's another y-intercept. That can't happen. We never said there was one there. And so hopefully you can see that the graph has to go towards this asymptote, go through this y-intercept, and has to go through this hole, but then make sure there's a gap where the hole is.